Welcome to the Juniper Connected Security Sky ATP module. This module provides an overview of Juniper Sky Advanced Threat Protection, or Sky ATP, and its basic purpose. This module also explains features of Sky ATP. This module also describes how to set up and enroll devices with Sky ATP. Finally, the module describes how to use the Sky ATP Web UI for monitoring. At the end of this module, you will be able to explain the purpose of Sky ATP, describe the features of Sky ATP, explain how to enroll devices with Sky ATP, explain how to use the Sky ATP Web UI. Malware or malicious software is software that attempts to gain access to a computer without the owner's knowledge. There are many types of malware, such as rootkit, ransomware, spyware, and bots. One of the many goals of malware is to infiltrate a rich target where it can carry out a wide range of undetected malicious activities over months or years, including data theft, espionage, and disruption or destruction of infrastructure and processes. Although methods vary, the commonality of these specialized attacks is that they are created to avoid detection by mainstream security technologies, such as antivirus, firewalls, and content inspection gateways. The threat landscape has evolved. Malware started out as experiments or pranks, but has recently become widespread and sophisticated. Attackers have migrated from using broad, unfocused tactics and are now creating specialized malware intended for a select target or groups of targets, with the ultimate goal of becoming embedded in the target's infrastructure. Preliminary results published by Symantec suggest that the release rate of malicious code and other unwanted programs may be exceeding that of legitimate software applications. With the emergence of these specialized threats, a new category of security has also emerged with the purpose of detecting, analyzing, and preventing advanced threats that are able to avoid detection by the more traditional security methods. Juniper Networks' solution for preventing advanced and emerging threats is Sky Advanced Threat Prevention, or Sky ATP, a cloud-based anti-malware solution for SRX series devices. Sky ATP is a cloud-based solution, and cloud environments are flexible and scalable, and a shared environment ensures that everyone benefits from new threat intelligence in near real time. Your sensitive data is secured even though it is in a cloud-shared environment. Security analysts can update their defense when new attack techniques are discovered and distribute the threat intelligence with very little delay. In addition, Sky ATP offers the following features: integrates with the SRX series device to simplify deployment and enhance the anti-threat capabilities of the firewall, delivers protection against zero-day threats using a combination of tools to provide robust coverage against sophisticated evasive threats, checks inbound and outbound traffic with policy enhancements that enables users to stop malware, quarantine infected systems, prevent data exfiltration, and disrupt lateral movement, provides high availability to provide uninterrupted service, provides scalability to handle increasing loads that require more computing resources, increased network bandwidth to receive more customer submissions, and a large storage for malware, provides deep inspection, actionable reporting, and inline malware blocking for web and email traffic. The diagram shows the components of Sky ATP. Click each thumbnail to learn more. The SRX devices use intelligence provided by Sky ATP to remediate malicious content through the use of security policies. If configured, security policies block that content before it is delivered to the destination address. For inbound traffic, security policies on the SRX series device look for specific types of files, like .exe files, to inspect. When one is encountered, the security policy sends the file to the Sky ATP cloud for inspection. The SRX series device holds the last few kilobytes of the file from the destination client, while Sky ATP checks if this file has already been analyzed. If so, a verdict is returned and the file is either sent to the client or blocked depending on the file's threat level and the user-defined policy in place. If the cloud has not inspected this file before, the file is sent to the client while Sky ATP performs an exhaustive analysis. If the file's threat level indicates malware, and depending on the user-defined configurations, the client's system is marked as an infected host and blocked from outbound traffic. The diagram shows an example flow of a client clean file download. In the first step, a client system behind an SRX device requests a file download from the Internet. The SRX device forwards that request to the appropriate server. Next, the SRX series device receives the downloaded file and checks its security profile to see if any additional action must be performed. Then, the downloaded file type is on the list of files that must be inspected and is sent to the cloud for analysis. In this example, Sky ATP has inspected this file before and has the analysis stored in cache. The file is not malware, and the verdict is sent back to the SRX device. Finally, based on user-defined policies and because this file is not malware, the SRX device sends the file to the client. For outbound traffic, the SRX device monitors traffic that matches CNC feeds that it receives, blocks these CNC requests, and reports them to Sky ATP. A list of infected hosts is available on the Sky ATP cloud so that the SRX device can block inbound and outbound traffic. Sky ATP uses a pipeline approach for analyzing and detecting malware. If an analysis reveals that the file is absolutely malware, it is not necessary to continue the pipeline to further examine the malware. Each analysis technique creates a verdict number, which is combined to create a final verdict number between 1 and 10. A verdict number is a score or threat level. The higher the number, the higher the malware threat. The SRX device compares this verdict number to the policy settings and either permits or denies the session. If the session is denied, a reset packet is sent to the client and the packets are dropped from the server. When a file is analyzed, a file hash is generated, and the results of the analysis are stored in a database. When a file is uploaded to the Sky ATP cloud, the first step is to check whether this file has been looked at before. If it has, the stored verdict is returned to the SRX device, and there is no need to reanalyze the file. In addition to files scanned by Sky ATP, information about common malware files is also stored to provide faster response. Cache lookup is performed in real time. All other pipeline techniques are performed offline. This means that if the cache lookup does not return a verdict, the file is sent to the client system while the Sky ATP cloud continues to examine the file using the remaining pipeline techniques. If a later analysis returns a malware verdict, then the file and host are flagged. The advantage of antivirus software is its protection against a large number of potential threats, such as viruses, trojans, worms, spyware, and rootkits. The disadvantage of antivirus software is that it is always behind the malware. The virus comes first, and the patch to the virus comes second. Antivirus is better at defending familiar threats and known malware than zero-day threats. Sky ATP utilizes multiple antivirus software packages, not just one, to analyze a file. The results are then fed into the machine learning algorithm to overcome false positives and false negatives. Static analysis examines files without actually running them. Basic static analysis is straightforward and fast, typically around 30 seconds. Here are the examples of areas that static analysis inspects. Metadata information, name of the file, the vendor or creator of this file, and the original data the file was compiled on. Categories of instructions used, Is the file modifying the Windows registry? Is it touching disk I/O APIs? File entropy. How random is the file? A common technique for malware is to encrypt portions of the code and then decrypt it during runtime. A lot of encryption is a strong indication that a file is malware. The output of the static analysis is fed into the machine learning algorithm to improve the verdict accuracy. The majority of the time spent inspecting a file is in dynamic analysis. With dynamic analysis, often called sandboxing, a file is studied as it is executed in a secure environment. During this analysis, an operating system or OS environment is set up, typically in a virtual machine or VM, and tools are started to monitor all activity. The file is uploaded to this environment and is allowed to run for several minutes. Once the allotted time has passed, the record of activity is downloaded and passed to the machine learning algorithm to generate a verdict. Sophisticated malware can detect a sandbox environment due to its lack of human interaction, such as mouse movement. Sky ATP uses a number of deception techniques to trick the malware into determining this is a real user environment. For example, Sky ATP can generate a realistic pattern of user interaction, such as mouse movement, simulating keystrokes, and installing and launching common software packages. Create fake, high-value targets in the client, such as stored credentials, user files, and a realistic network with internet access. Create vulnerable areas in the OS. Deception techniques by themselves greatly boost the detection rate while reducing false positives. They also boost the detection rate of the sandbox that the file is running in because they get the malware to perform more activity. The more the file runs, the more data is obtained to detect whether it is malware. Sky ATP uses its own proprietary implementation of machine learning to assist in analysis. Machine learning recognizes patterns and correlates information for improved file analysis. The machine learning algorithm is programmed with features from thousands of malware and goodware samples. It learns what malware looks like and is regularly reprogrammed to get smarter as threats evolve. Identified locations and their associated IP addresses can be profiled within the Sky ATP Cloud GeoIP data feed. In the event of fraudulent activity or known illegal traffic that is sourced from a particular geography, Sky ATP can filter network traffic based on the location of a host. You can base packet filtering on blocks of IP addresses that have been identified and attributed to a particular geography. GeoIP uses a dynamic address entry or DAE infrastructure. A DAE is a group of IP addresses, not just a single IP prefix, that can be imported into Sky ATP from external sources. These IP addresses are for specific domains or for entities that have a common attribute, such as a particular undesired location that poses a threat. The administrator can then configure security policies to use the DAE within a security policy. When the DAE is updated, the changes automatically become part of the security policy. There is no need to manually update the policy as the cloud feed URL is automatically set up for you when you run the ops script to configure your SRX series device. Here are the details of the steps shown on the diagram. 1. The SRX devices are enrolled on the Sky ATP Cloud through the web portal, and they are configured to block traffic from certain geographic locations. 2. The Sky ATP Cloud delivers threat intelligence that identifies geographic locations that pose a threat to network security to the SRX devices. 3. The SRX devices permit traffic from allowed geographic locations. 4. The SRX devices deny traffic from blocked geographic locations. CNC servers remotely send malicious commands to a botnet or a network of compromised computers. The botnets can be used to gather sensitive information, such as account numbers or credit card information, or to participate in a distributed denial of service or DDoS attack. When a host on your network tries to initiate contact with a possible CNC server on the Internet, the SRX device can intercept the traffic and perform an enforcement action based on real-time feed information from Sky ATP. The Web UI identifies the CNC server IP address, its threat level, and number of times the CNC server has been contacted. The example shows a host in a data center that is infected with a CNC bot. Here's how Sky ATP stops this threat. 1. CNC prevention is configured on the SRX device. 2. Sky ATP pushes the known CNC server's feed to the SRX device. 3. The compromised host attempts to contact the CNC server. 4. The SRX series device stops the communication, and depending on the threat level verdict, the host might be automatically blocked. Then the infected host is reported to Sky ATP, and you can view it in the Sky ATP Web UI. With email management for SMTP, enrolled SRX devices transparently submit potentially malicious email attachments to the Sky ATP cloud for inspection. Once an attachment is evaluated, Sky ATP assigns the file a threat score between 0 and 10, with 10 representing the most malicious value. The Internet Message Access Protocol, or IMAP, is supported for protection. Configure Sky ATP to take one of these actions when an email attachment is determined to be malicious. Quarantine malicious messages. If you select to quarantine emails with attachments found to be malicious, those emails are stored in the cloud in an encrypted form, and a replacement email is sent to the intended recipient. That replacement email informs the recipient of the quarantined message and provides a link to the Sky ATP Quarantine Portal where the email can be previewed. The recipient can then choose to release the email by clicking a release button or request that the administrator either release or delete the email. Deliver malicious messages with warning headers added. When you select this option, headers are added to emails that most mail servers recognize and filter into spam or junk folders. Permit. You can select to permit the email and the recipient receives it intact. If the recipient selects to release a quarantined email, it is allowed to pass through the SRX series with a header message that prevents it from being quarantined again, but the attachments are placed in a password-protected zip file. The password required to open the zip file is also included as a separate attachment. The administrator is notified when the recipient takes an action on the email, either to release or delete it. If you configure Sky ATP to have the recipient send a request to the administrator to release the email, the recipient previews the email in the Sky ATP Quarantine Portal and can choose to delete the email or request to release. The recipient receives a message when the administrator takes action, either to release or delete the email. There are many popular web-based email services, such as Gmail or Yahoo Mail, and so, what happens if your users use a web-based email client? The good news is that Sky ATP can scan the attachments that users download using these web-based email clients. The scanning procedure is exactly the same as when users download any other type of traffic through HTTP. As far as Sky ATP is concerned, there is no difference in downloading a file from a web server or through a web-based email client. The important thing to keep in mind is that whichever actions you specify under the HTTP section of the Sky ATP configuration will apply to attachments that users download through a web-based email client. This means that you do not have the quarantine options that are available if your users download email attachments through SMTP. Emails are checked against administrator-configured blacklists and whitelists using information, such as envelope from or mail from, envelope to or RCPT2, body sender, and body receiver. If an email matches the whitelist, that email is allowed through without any scanning. If an email matches the blacklist, It is considered to be malicious and is handled the same way as an email with a malicious attachment. Although Sky ATP is a free add-on to an SRX series device, you must still enable it prior to using it. To enable Sky ATP, perform these tasks. Obtain a Sky ATP license, basic or premium. This step is optional, as you can use the free license. However, the premium and basic licenses come with many features that the free license does not. The free license provides comprehensive analysis and reporting for executable files, infected host feed, and inline malware blocking. The basic license provides the features of the free license and CNC feeds, GeoIP feeds, custom feeds, and third-party feeds. The premium license provides the features of the free and basic licenses and comprehensive analysis and reporting for all supported file types in Sky ATP. For hardware-based devices, such as the SRX 1500, you do not need to install any license keys on the SRX device. Instead, the entitlement is handled on the cloud and is tied to the chassis serial number of the device. For VSRX devices, the entitlement is tied to the software serial number, and you must install a Sky ATP license on the VSRX devices. You must have a valid Customer Service Center or CSC account for the premium, basic, or free license models. So, you must register an account on the Sky ATP Cloud Web Portal. To register on the Sky ATP Cloud Web Portal, you must first navigate a web browser to the Sky ATP Cloud Web Portal page and log in with your single sign-on or SSO or your CSC username and password. After you log in, you are guided through a wizard for creating an account. Download and run the Sky ATP script on your SRX series device. After you are registered and logged into the Sky ATP Cloud Web Portal, you must navigate to the Device All Devices workspace. In this workspace, you must click Enroll that gives you an operational script, which is associated with a URL, to run on your SRX series devices. There are 6 steps for registering with the Sky ATP portal. Click each step to learn more. The web UI for Sky ATP is very similar to the SRX series device JWeb UI, which makes administering the two platforms easier. The Sky ATP dashboard not only provides a way to navigate through the web UI, it also provides reports in the form of widgets on the dashboard. These widgets can provide valuable information about compromised hosts, file scans, CNC server, and malware locations, as well as other information. These widgets can be adjusted and moved around on the dashboard. The dashboard also contains tabs that enable you to efficiently organize the widgets on the dashboard. In the top right corner, you can click the User menu to get options to log out or adjust the user profile. To navigate to another workspace, you must hover your mouse pointer over the navigation bar, which then expands, revealing the different workspaces: Dashboard, Monitor, Devices, Configure, and Administration. The Sky ATP uses a Juno's OS operation or op script to help you configure your SRX series device to connect to the Sky ATP cloud service. There are 2 choices depending on the version of code that you are running on your SRX series device. Copy the entire line of code to your clipboard and be aware that it is much longer than what is displayed on the screen. You can acquire the OP script by logging into your security realm within the Sky ATP Web portal and navigating to the Devices or All Devices workspace. When enrolling devices, Sky ATP generates a unique OP script for each request. Basically, each time you click Enroll, you will get slightly different parameters in the OP script. Sky ATP requires that both your routing engine, or control plane and packet forwarding engine, or data plane can connect to the Internet, but the interface that connects the SRX to the Internet should not go through the management interface. For example, you should not use the FXP0 interface to connect to Sky ATP, and you should instead use another transit interface, such as GE0/0/0. For SRX 340, SRX 345, and SRX 550M series devices, you must run the CLI Set Security Forwarding, Process Enhanced, Services, Mode Configuration command before running the operational script or before running the Set Services Advanced Anti-Malware Connection Configuration command. The image shows an example of using the OP script. Paste the text from the clipboard into the window next to the Enroll button. Then, enroll the SRX series device with Sky ATP. This process will take a few minutes to complete, in which the enrollment status information will be displayed on the screen. If the enrollment is successful, there is a green Successful status that will be displayed on the page. If enrollment is unsuccessful, there are a few options to check on. If the SRX device is not properly synchronized with a Network Time Protocol or NTP server, then the device enrollment fails. Another item that can cause device enrollment to fail is if the host name contains characters, such as the asterisk or @ symbols. Note that the maximum size for a host name is 24 characters. The host name for a device can only contain alphanumeric characters and the dash or underscore symbols. Also, the host name cannot have too many characters or device enrollment fails. The output lets you know if the host name is too long. If for some reason the device enrollment fails, it is recommended to first disenroll the device using the disenroll OP script found in the Devices All Devices workspace in the Sky ATP Web UI for your security domain. Then you should reboot the device, fix the problem, and try running the enroll OP script again. You do not need to open any ports on the SRX series device to communicate with the cloud server. However, if you have a device in the middle, such as a firewall, then that device must have ports 8080 and 443 open to enable the SRX device to initiate communication with Sky ATP. Note that Sky ATP never attempts to initiate connections to your SRX devices. If those ports are blocked anywhere along the path in which the SRX device needs to communicate with Sky ATP, then device enrollment fails. After device enrollment completes successfully, you can check the status of the device enrollment by examining the Devices All Devices workspace in the Sky ATP Web UI. Note the tier field, which shows which type of license is in use, and the Last Activity field, which shows when the last time the device submitted a file for scanning. Note that if the Last Activity field is blank, this means that the enrolled device has not submitted any potentially malicious files for inspection. To get to the Configure section, you must hover your mouse pointer over the navigation bar on the dashboard to expand it, and then select the Configure option. From there, a new menu appears that enables you to configure whitelists and blacklists, email management, device profiles, and the global configuration. Generally speaking, a whitelist is simply a list of known IP addresses that you trust, and a blacklist is a list of IP addresses that you do not trust. You use URLs or IP addresses when configuring whitelists or blacklists. For Sky ATP, whitelists define locations where files downloaded from do not need to be inspected for malware. Blacklists define locations from which file downloads are blocked. There are 4 kinds of whitelists and blacklists. All are configured in the Sky ATP Cloud Web UI. The priority order is as follows: Custom Whitelist, Custom Blacklist, global whitelist, global blacklist. If a location is in multiple lists, the first match wins. For example, if 10.1.1.1 is included in a custom whitelist and a custom blacklist, the IP address is permitted. If an IP address is included in a custom blacklist but is also a part of the global whitelist, then the IP address is blocked. Note that the global whitelist and global blacklist contents are hidden. You cannot view or edit them. Sky ATP profiles let you define which files to send to the cloud for inspection. You can create Sky ATP profiles only with the Sky ATP Cloud Web UI. You cannot create the profile using CLI commands. You can, however, use CLI commands to view the profile on the SRX series device to make sure it matches the one in the cloud. You can also define the maximum file size requirement per category to send to the cloud. If a file falls outside of the maximum file size limit, use the Advanced Anti-Malware Policy Fallback option to either allow or deny the file to be downloaded. Note that the maximum file size that can be inspected is 32 MBs. Also, if you are using the free version of Sky ATP, you are limited to just the executable file category. Sky ATP periodically polls for new and updated content and automatically downloads it to your SRX devices. There is no need to manually push the device profile. The table shows a list of categories, which is useful because instead of having to list every single type of file you want to scan, such as .tar, .exe, and .java, Sky ATP lets you pick file categories to send to the cloud. This table lists the categories and the file types associated with each category. The connection to the Sky ATP cloud is launched on demand. It is established only when a condition is met and a file or URL must be sent to the cloud. The cloud inspects the file and returns a verdict number from 0 through 10. A verdict number is a score or threat level. The higher the number, the higher the malware threat. The SRX series device compares this verdict number to the Advanced Anti-Malware Policy settings and either permits or denies the session. If the session is denied, a reset packet is sent to the client and the packets are dropped from the server. You can configure the advanced anti-malware policies in the CLI on the managed SRX devices that are communicating with Sky ATP or by using Security Director. This configuration occurs under the Edit Services Advanced, Anti-Malware Policy, Policy Name, Configuration Hierarchy in the Juno CLI. First, you must define the application to match with the verdict threshold. You can configure the SRX devices to examine HTTP and SMTP. These matching options might make it seem that Sky ATP cannot examine encrypted traffic, but that is not the case. To examine encrypted traffic, you must configure and apply Secure Sockets Layer or SSL proxy by configuring forward or reverse SSL proxy. After configuring the SSL proxy for the traffic, the SRX devices can decrypt and examine the traffic. The verdict threshold relates to the verdict number that Sky ATP returns after examining a file. For example, if you set the verdict threshold to 6, and Sky ATP scans a file and returns a verdict number of 5, then the file is allowed. However, if Sky ATP scans a file and returns a verdict number of 8, then the file transfer is acted upon. Next, you must reference the Sky ATP inspection profile that you want to use for the policy. Remember that Sky ATP inspection profiles are created in the Sky ATP Web portal, and then they are pushed to the enrolled SRX devices. But what happens if a file is not scanned because it is too large or for other reasons? This situation is what fallback options are for. You can specify what happens if a file is unable to be scanned. With the fallback options, you can block or permit the file and create a log file if a fallback operation occurs. Lastly, you can configure logging for whitelist and blacklist hits as well as the default notifications. The Global Configuration Workspace enables you to set a global threat level threshold, and you are able to set up an email alert when a file is scanned for a specific threat level threshold or higher. The example shows that an email will be sent out if a file is scanned with a threat level threshold of 4 or greater. The global threat level threshold enables you to add hosts to the infected host list if a certain threat level threshold is reached. For example, if you configure an advanced anti-malware policy that has a verdict threshold of 7 and the global threat level threshold is set to 9, then the global setting never comes into play. However, if you have an advanced anti-malware policy that has a verdict threshold of 7 and a global level set to 5, and a file is scanned with a 5 or 6 threat level, then the host is added to the infected host list, but no action is taken on the host. If a file comes in with 7 or greater threat level, then the host is added to the infected host list and the action is taken that is specified in the advanced anti-malware policy. The SRX series device now needs configuration to work with the threat level feeds and to send information about files traversing it to Sky ATP. The first step is to create a threat prevention policy and configure the services and threat levels needed to monitor the traffic. Each category can be independently configured for different threat level responses in each policy. Multiple threat prevention policies can be created to be applied to different security policies. Each security policy can only have one threat prevention policy assigned to it. Each of the 4 threat settings are optional in each policy. Move to the Configure, Security Services, Threat Prevention, Policies Workspace to add or edit the threat prevention policies. Each policy needs a unique name and at least one category configured to analyze traffic. The threat prevention policies must be applied to a security policy to take effect. Move to the Configure, Security Services, Security Policy Rules to add the threat prevention policy to the security policy. The threat prevention policy containing the CNC server, the malware, and the infected hosts configuration needs to be applied to the security policy allowing Internet traffic. To get to the Monitor section, you must hover your mouse over the navigation bar on the dashboard to expand it and select Monitor. From there, a new menu appears that enables you to examine infected hosts, CNC servers, file scanning results, and email quarantine results. The Monitor Hosts workspace gives you a clear view of all the infected hosts in your network in the Sky ATP Web UI. You can note here the threat level, the block status, and the investigation status of each infected host. To gain further insight on an infected host, you can click its IP address in the Hosts field. Infected hosts are systems where there is a high confidence that attackers have gained unauthorized access. When a host is compromised, the attacker can do several things to the computer, such as send junk or spam email to attack other systems or distribute illegal software, collect personal information, such as passwords and account numbers, disable your computer's security settings to allow easy access. In Sky ATP, infected hosts are listed as data feeds and are also called information sources. The feed lists the IP address or IP subnet of the host along with a threat level. Once identified, Sky ATP recommends an action, and you can create security policies to take enforcement actions on the inbound and outbound traffic on these infected hosts. Sky ATP uses multiple indicators, such as a client attempting to contact a CNC server or a client attempting to download malware, and a proprietary algorithm to determine the infected host threat level. The diagram shows an example of how devices are labeled as infected hosts by downloading malware. The steps displayed are 1. A client with IP address 10.1.1.1 is located behind an SRX device and requests a file to be downloaded from the Internet. 2. The SRX device receives the file from the Internet and checks its security policies to see if any action needs to be taken before sending the file to the client. 3. The SRX device has an advanced anti-malware policy that requires files of the same type that was downloaded to be sent to the cloud for inspection. This file is not cached in the cloud, meaning this is the first time this specific file has been sent to the cloud for inspection. So the SRX device sends the file to the client while the cloud performs an exhaustive inspection. 4. In this example, the cloud analysis determines that the file has a threat level greater than the threshold, indicating that the file is malware, and sends this information back to the SRX device. The client is placed on the infected host list. 5. Sky ATP blocks the client from accessing the Internet. The client remains on the infected host list until an administrator performs further analysis and determines it is safe. The image shows the details of an infected host. The first thing you might notice is that the host status field has been updated to show that the host has a high threat level and has been automatically blocked. If the host had a lower threat level, it might not automatically be blocked, and you might only receive a recommendation of blocking the host. The host status can be any of these states. Threat level 0, clean, no action is required. Threat level 1 to 3, low threat level since date level changed. Recommendation, disable this host. Threat level 4 to 6, medium threat level, level number since date level changed. Recommendation, disable this host. Threat level 7 to 10, high threat level, level number since date level changed. Host has been automatically blocked. The investigation status field defaults to open and will remain in this state unless you change it. This status can be changed to in progress or one of the resolved statuses shown in this example. Note that if you mark the host with any of the resolved statuses, the host will be unblocked and it will be allowed to communicate with other hosts. This communication will stop again if the host is involved in another incident, at which point it will be blocked again if the threat level is high enough. The policy override for this host field enables you to change how this host is treated. You can use the user-configured policy, which is the default. You can choose to always include the host in the infected host feed, or to always exclude the host from the infected host feed. The host threat level graph shows a color-coded graphical representation of threats to this host displayed by timeframe. You can change the timeframe, and you can slide the graph backward or forward to zoom in or out on certain times. When you zoom in, you can view individual days within a month. The graphic at the bottom of the graph displays the Current Threats field and shows individual details about the current incidents. Note that you can click the links in the description field to find out more information about the individual incidents that the host has experienced. After you click the file signature, you will see the details about the file that tells you what malware scanners say about this file, and a complete list of hosts that downloaded this file. Also, the Workspace tells what malicious behavior was found in the file. The Report False Positives button launches a new screen, which lets you send a report to Juniper Networks, informing Juniper of a false positive or a false negative. Juniper will investigate the report. However, this does not change the verdict. If you want to make a correction, that is, mark system as clean, you must do it manually. The top of the page provides a quick view of this information. Threat level. This is the threat level assigned. It ranges from 0 to 10. This box also provides the threat category and the action taken. Top indicators. In this box, you will find the malware name, the signature it matches, and the IP address or URL from which the file originated. Prevalence. This box provides information on how often this malware has been seen, how many individual hosts on the network downloaded the file, and the protocol used. The different tabs provide additional information about the file signature. General displays general information about the file signature, such as the threat level, global prevalence, file name, category, size, and other details. Behavior analysis gives additional details about the behavior of the signature. Network activity gives information about the network activity of the signature. Behavior details gives additional information about the behavior of the signature. Welcome to the lab. You have reached the end of this module. In this module, you learned to explain the purpose of Sky ATP, describe the features of Sky ATP, explain how to enroll devices with Sky ATP, explain how to use the Sky ATP Web UI.